Okay, one last idea is, before we get to nonlinear functions, one last idea has to do with graphing planes based on their intercepts. And so now we're on page 44 and 45. And this is to say if we wanted to graph something like x plus y plus z equals 3. Now this is our first plane that used all three variables, but we're going to use a trick that we often used back in R2, which was if it was a line, a linear thing, and this one is linear, we can look at that by looking straight from the exponents. There's no squares or square roots or cubes, nothing nonlinear in any of our variables. Therefore, this is a linear function in R3. And so it's got to create something flat. In R3, the flat thing is not the line that it was here, it gets extended to a surface that is a plane. So this is a plane, and what we're going to do is a trick from R2. When we were graphing lines here, sometimes you used your y-intercept and your x-intercept to graph the line. We're going to do the same thing here. We're going to find an x-intercept for this. All right, well, let's think about it. In R3, what does an x-intercept mean? It's a place where your surface touches the x-axis. To be on the x-axis, what does that say about y and z? They have to be 0, right? So if y and z are both 0, x equals 3 is our x-intercept. That's where we cross the x-axis. So we have an x-intercept at the point, 3, 0, 0. We have a y-intercept at the point 0, 3, 0. And a z-intercept, same thing. You'd set the x and y to 0, z is 3. So for this particular example, all the intercepts are 3. And that one's actually really easy to graph on your finger coordinate system. Just go 1, 2, 3 units up each axis, 1, 2, 3, connect the dots, and you see a triangular section of the plane. It's also very easy to graph this one in three-dimensional space. 1, 2, 3 along the x is my intercept, 0, 0, 3, 0, 0. 0, 3, 0 is the y, point for the y-intercept, and 3 up here. I can just connect the dots and know that that is a triangular section of the plane. This one's a good one to view in your corner coordinate system. So I'm looking over at my corner, go along the x, the y, and the z, 3 units, and it makes a little lean-to into the corner, right?